Hello math enthusiasts and welcome back. From the last couple of sessions, we have been observing various number systems. Continuing that streak today, we will observe the octal number system. So without any further ado, let's get to learning. Outcomes of today's session. Today, we will acquire the understanding of the octal number system details. First, what is octal number system? Second, octal representation. Third, binary to octal number system. And fourth, octal number system general representation. What is octal number system? Octal refers to the base 8 numbering system. It comes from the Latin word for 8. The octal numbering system uses the numerals 0, 1, 2, 3, 4, 5, 6, and 7. Now, this number system has the symbols 0, 1, 2, 3, 4, 5, 6, and 7. So in this, the total number of symbols are 8. Hence, the base of the number system is 8. And that's the reason why this number system is called octal number system. Octal number system has a spatial significance with the 3-bit binary numbers. Observe this chart. Now, in the previous session, we learned that for 3-bit binary numbers, the least significant bits place has the place value 2 raised to the power of 0, that is 1. Then the next bit towards the most significant bit has the place value 2 raised to the power 1, and that is 2. And finally, the most significant bit has the place value 2 squared or 4. Now, every 3-bit binary number will represent an octal symbol. Let me show you that. So 000 in octal is 0. 001 in octal is 1. This is because the 1 is placed under the bit place having the place value 1. Now, 010 in octal is 2 because 1 is placed underneath 2. Then 011 in octal is 3 because 1s are placed underneath 2 and 1, and 2 plus 1 is 3. Thereafter, 100 in octal is 4, as 1 is placed beneath 4. Next, 101 in octal is 5. Observe. Here 1s are placed under the place value 4 and 1. Then, 110 in octal is 6. Why? Because clearly the 1s are placed underneath 4 and 2, and 4 plus 2 is 6. Finally, 111 in octal is 7. Now, these are all the symbols of the octal number system. Now, this number system comes really handy if we want to represent binary bit stream using lesser number of symbols. For an instance, let's consider this binary bit stream. Here, the presence of the subscript 2 clearly signifies that this is indeed a binary bit stream. Well, memorizing this will be really hard for sure. Here, the octal representation will come at rescue. So what we will do, we will first make groups of 3 bits from the least significant bit to the most significant bit. Thereafter, we will just replace each group with their equivalent octal value. Now, 010 is 2, so these 3 bits can be represented by 2. Then, 011 is 3 in terms of octal. Again, we have 010, which is clearly 2. Then, we have got 111, which in octal is 7. Finally, we have got 100, which in octal is 4. So the 15 bits long binary bit stream can now easily be represented using only 5 octal digits. So the value of the same in octal is 47232 base 8. Another additional fact, usually octal values are written adding a 0 as its prefix. The value can also be written as 047232 due to the 0 in the prefix. The base 8 is already implied. Now, let's observe how the number are formed in octal similar to decimal. Here as well, once we have exhausted all the 8 symbols that we had in order to form the next numbers, we will select the second symbol, that is 1. And alongside 1, we will use all the symbols of octal, that is 0 to 7. So after 7, remember that it is octal and we don't have any symbol beyond 7 in here. So the single digit numbers will be only from 0 to 7. So after 7, the next numbers will be 1, 0, 1, 1, 1, 2, and so on till 1, 7. Another fact, the number after 7 is 10. We can't call it 10 because 10 is a number pertaining to the decimal number system. The same rule is applied to all of the numbers after 7. Now, after 17, since we have no symbols left for the least significant digits place, we will choose the next symbol in line, that is 2 in place of 1, and perform the same drill. So, the number after 17 is 20. Now, all these places where the symbols are changing as the numbers progress have the place value of 8 raised to the power of 0. Now, why it is 8? Well, that's because the base of the number system. We only have 8 symbols in octal, right? Due to this, in the place next to the least significant digit, observed there are 8 ones and then 8 twos. So, the symbols are changing after 8 instances. That gives the place value 8 raised to the power 1. Now, eventually, when for the 8 raised to the power 1's place, we have the symbol 7. And for 7, we have used up all the symbols in the least significant digits place in order to form the next octal number. We will introduce a new place having the place value of 8 squared because for these two places, we already have exhausted the symbols that we had. So after 7, 7, the next number will be formed placing the symbol 1 in the 8 squared place, and then 2 places will be reset to zeros. Eventually, when we will reach the number 177, we again will have used up all the symbols in these 2 places. So, the next number will be formed by placing the next symbol after 1. That is 2 in the most significant digits place, and again, these 2 places will be reset to zeros. So, this is how octal number system works. Now, before moving ahead, I have 2 questions for you. In octal, what comes after the number 767 and what comes before the number 440? Feel free to write down your answers in the comment section. Now, coming to the general representation, consider a 5-digit octal number. Now, all these places can have any symbols from 0 to 7, and being octal, the base of the number would be 8, and the place values will be 8 raised to the power of 0, 8 raised to the power of 1, 8 squared, 8 cubed, till 8 raised to the power of 4. So in this session, we learned about the octal number system and the relationship it has with binary number system. Practical application of octal number system. The octal number system is widely used in computer application sector and digital numbering system. The computing system uses 16-bit, 32-bit, or 64-bit word, which is further divided into 8-bit words. The octal number is also used in the aviation sector in the form of a code. Another application. Octal became widely used in computing when systems such as the UNIVAC 1050, PDP-8, ICL1900, and IBM mainframes employed 6-bit, 12-bit, 24-bit, or 36-bit words. Octal was an ideal abbreviation of binary for these machines because their word size is divisible by 3. Each octal digit represents 3 binary digits. Alright people, that will be all for octal number system. We will observe another interesting number system, so I hope to see you in the next one.